subject requires a base of signals and systems. Again, you would see in signals and systems, we had seen that one of the major applications of that subject was in signal processing and image processing. It is the same slide that you have seen in the bridge course. So without some basic knowledge or understanding of that signals, it may be difficult to proceed with these two subjects, because actually this subject is a combined subject of signal processing and image processing. Most of you would recall the fundamentals, that is x of t is the input, y of t is the output for a system, and this is for a continuous time case, and for a discrete time case it is x of n and y of n. And we had also seen what is a system and what is a signal. In that case, we had discussed signal is a function of an independent variable, either a continuous time t or a discrete time n, and it represents a mathematical quantity or variable. In other words, it could represent pressure, it could represent voltage, it could represent current, it could even represent a human being. Signal could be also the presence of a human being, as is usually done in an embedded system application, where you will be counting the number of people, etc. And system is the response to input signals by producing the output signals. Difference equation, which is necessary for understanding the basics of the subject. So if we are going to consider the output and the input, we recall that the output is going to be y and the input is going to be x, and delayed versions of output would be given by y of n minus k, where k could vary from 0 to n. Similarly, for input, we could have delayed versions from n minus k, where k could vary from 0 to n. Since we are going to have such a variation, you know that the values of a and k would be different. They could be 0 also in some cases, they could be present in some cases, they could be very large also in some cases. As a result, the expression of the system would change. And the major thing why this was discussed is that the order of the system is going to tell you something about the difference equation, and it depends on whether n is greater or n is greater. In most of the systems, you would see that n is generally greater than m, thereby the order of the system is generally ruled by the output. And this tells us that it is bound by the number of storage devices that are present in the system. This is as far as the difference equation is concerned, and as has been mentioned, n is generally greater than m, and hence the order is given only by n. Again, just taking a simple example of a difference equation, we would remember that y of n plus y of n minus 1 plus 1 by 4 y of n minus 2 is going to be equal to x of n plus 2x of n minus 1. Here, what we mean is we have the present input, we have the past input, that is what is x of n minus 2. We do not have the past input, which might be represented by x of n minus 2. However, we have a past output given by y of n minus 2, and here you can see that the value of that a is 1 by 4, the value of this a is 1, and the value of this a is also 1, which means a0 is 1, a1 is 1, a2 is also 1. Similarly, here b0 is 1 and b2 is 2. So this is what is the example of a difference equation, and why this difference equation has been considered is the difference equation forms the fundamental for filters, whether it is IIR filter or FIR filter in signal processing. Hence, this difference equation has been introduced, and so much time has been spent on explaining what is this difference equation. And as can be seen, what is the order of such a difference equation? You can see that the highest order is 2, which means the maximum number of memory elements in this particular system is going to be 2. And as was said in the previous case, in most of the difference equations, we see that the output elements are greater than the input elements, and usually the order of the system is ruled by the output rather than by the input. You will see that there is going to be a slight modification in this expression when it comes to the concept of filters. Till now we were discussing about the time domain. Are we not satisfied with the time domain? Apparently no, because one of the major problems of time domain is a concept maybe you would remember called as convolution. This is a problem which is taking a lot of time for implementation. As a result, we would like to do many of the implementations in the frequency domain. And here you would see two frequency expressions, basic expressions rather. The first one is the Fourier series. It is given by f of x is equal to a0 by 2 plus n equal to 1 to infinity an cos nx plus n equal to 1 to infinity bn sin nx. This tells us that the DC component or the shift of the signal is represented by a0, and any signal could be represented as the sum of cosines and sines, and the percentage of cosines and sines in each frequency varies. That is why we have the value as an and cos nx. Same thing bn and sin nx. This is just an introduction, so we are not going too deep into it. And the next thing is another expression which we had called it as Fourier transform. The Fourier transform is a step over the Fourier series because it helps us to understand the periodic signals which are generally analyzed in Fourier series, go a step further and could be analyzed better with Fourier transforms. So our expression is going to become minus infinity to plus infinity f of t e power minus j omega gt, and you would recall that the inverse could got the time domain value could be f omega e power j omega t omega. So why this frequency expression explained was whether it is going to be in a signal or in an image. We will see that one of the important concepts which we are going to discuss is going to be the discrete Fourier transform, at least the basics, which is going to be either in the 1D or in the 2D. So this is what is our expression for Fourier series and for Fourier transforms. Though I'm not going too deep into it, this is just a recall of what you are already aware. Next, we go on for Z transforms. Why the Z transforms is necessary is that many times when the signal is in the time domain, it is given as y of n is going to be equal to x of n plus 2 into x n minus 1 plus 4 x n minus 2. This is just a sample given just to make you understand what is going to be the expression. And you would recall that when we substitute z is equal to e power j omega t, where this omega t is, or this omega is actually the digital omega. Again, those concepts maybe you don't recall, and just introducing them could be used for substituting z. Why this was introduced is y of z, if you take the z transform, could be given as x of z into 1. When it is having x of n minus 1, we could write it as z minus 1 plus z minus 2. This is what is the basics of the Fourier transform and the Z transform. Do we require all this? Are we going to discuss this in detail? If we are going to discuss this in detail, then we should go ahead with signal processing, and you would see that in signal processing we would be having a 1D signal, that is one of the major aspects of the signal. We would have DFT, we would have FFT, we would have IIR filters and FIR filters. These are the portions that we will be considering in signal processing, considering either one or two methods in each of the cases. We also have DFT properties. Some important properties will also be considered. The next thing that we are going to consider is the basics of image processing, where an image is basically a 2D signal, and since it is a 2D signal, we would be considering the major aspect, that is image sensing and acquisition. What is this image sensing and acquisition? Most of you have mobile cameras which can take the photographs with very good resolution, and this photograph is quite sufficient to start our image processing problem. If we have a photograph, can we start image processing? Definitely yes. We need to go about with some aspect called as pre-processing, and this pre-processing could be done in different ways, and it is this pre-processing which forms the fundamental to image analysis. The success of an image analysis depends on how well you have done the pre-processing. This is what is going to be basically what we are going to consider in image processing. I have given it just in 4 or 5 points. However, the syllabus, as you can see, is running for almost a page. So though we have the signal processing and we have image processing, I have decided to go about with image processing. The reason being, it would be easier for you to understand the concepts rather than going mathematical and perhaps making you more tensed seeing those omega and digital omega, analog omega, etc. So let us start basically now with image processing. This is going to be the start of our syllabus, that is, what is image processing, how can we do it, what is the challenge behind image processing. Most of us are aware that computers are very fastest, any term you could use, and they're very good at manipulating numerical data. Since they are very good at manipulating numerical data, the thought is, why can't it also do image recognition? And that usually we see computers are not having sufficient ability. The reason being, the human beings have a recognition ability. When you see your friend after 3 years, you remember that this is so and so, he was sitting next to you in the classroom and he was studying the subject with you. He got this mark in signal and image processing also, you may mention. Next, one of the other things that human beings have is a human brain which is very sophisticated and it can recognize objects within a few seconds. Also, human beings have sensory organs like smell, touch, taste, hearing, and visual information. And with these things, it is very difficult for us to have a good comparison between computers and human beings. And most of us accept that a picture speaks 1,000 words. As a result, if we have an image, that could tell a lot about what is the situation that is existing or what is the problem that is going to be there. Why do we want to give significance to images? When we talk images, if you have photographs of happy pictures that are given in a digital album, and you are aware that nowadays doctors use medical images for diagnosis, even this is being done remotely, and forensic experts use fingerprint recognition. There are still thousands of applications in remote sensing, industrial technology, and so many other aspects of automation. So if this is what is the concept of a photo or an image, then one thing is very clearly understood, that it is a very powerful tool in communicating. And with the digital revolution, wherein cheap digital cameras are available, we could use images to effectively communicate the ideas. And a lot of images are used in daily lives, the portraits, paintings, photos in magazines, internet, so on and so forth. So if so many images are available, can't we take those images and start studying this subject? This is what is going to be our thought, and this is what we need to consider. So let us go on to see what could be. Most of you are aware, an image is a 2D signal. I specifically put this particular slide because some of you still feel that an image is a 2D signal. However, you would see that an image has got two coordinates. One is the height of the person indicates the y-axis, and his standing on the ground tells us about the x-axis. On the other hand, a video is going to have x, y, and t. As a result, it is called a 3D signal. A video is not the scope of our subject, so we may not be discussing a video other than considering a simple practical case to just see how a video could be analyzed as an image on a frame-to-frame basis. So hence, an image is a 2D signal having a width, or you could call it as depth, and a height which represents the y-axis, thereby giving a value, or generally you would see that an image is represented by a value f of xy. So it's a function of xy and the intensity of the image. At each value it gives you the intensity that is going to be given by f of xy. We will see more about it in the coming slides. What is this image processing? Again, the same term fxy has been introduced. We are trying to imitate real world objects. So what are we going to do? Let us assume that you are sitting in your home, there is a tree nearby. You are just going to take a photograph of this particular tree and you would like to locate if a bird is sitting on the tree. Is it possible? Yes, it is going to be possible, and it is this aspect that is going to be, it looks easy for you that a bird is sitting on a tree, can't we find out? But please recall that such an algorithm has to be built into the system for the computer to understand that in this particular photograph, the bird is sitting at this particular location. Hence, this introduces the challenge of image processing. And another difference that we would again see in image processing is that image is generally available. We would like to digitize it, sample and quantize it for processing by a computer. Digital images are only available, so this particular concept may not be very difficult. Directly we can sample and quantize an image. And if we go in, we could see that image, which is a 2D signal, is given by f of xy, and as I mentioned in my previous slide, the value of f of xy represents the amplitude or the intensity of the image. That means, suppose it's a black color, it may give me some intensity. If it is white color, it may give me some other intensity. You know that both the values are not going to be the same. This is what is meant by the amplitude and intensity of an image. We go on to what is going to be the basics that is necessary for understanding an image processing problem. The first problem is going to start with acquire the image or image acquisition. In other words, we may require different types of camera for different applications. I mentioned that a mobile camera is efficient, but if you are going to take some satellite images, definitely you are aware that that cannot be done efficiently by a mobile camera. So, depending upon the application, the image acquisition plays a very major role in your problem. And as mentioned earlier, the resolution of the image is also going to be highly important to understand how the image could be analyzed or understood. So what do? I got an image, fine. I got it from an ordinary camera. What should I do next? The first thing that could be done is I would go in for some form of a conversion which has not been mentioned here, and a resizing, which is actually called as a pre-processing concept, wherein I would like to represent it such that it is easily understood or it is easily processed by a computer. For that, we would like to go in for either, if it's a color image, it will occupy more space. So I would prefer to go for a binary image or for a grayscale image. We will see more about those images in the later sessions. However, our aim would be to convert an image into a form which is going to occupy less space in the computer. That is going to be our first step. We may go for image enhancement or image restoration. Sometimes you may have some background. You may want to remove that background. You may want to do so many other processes. And one of such process is the morphological image processing, whereby using some structural elements, some parts of the image could be removed. Image compression is a concept which is very important in embedded systems because of the fact that you could compress the image and transmit it. However, due to the constraint of time, we may not be going for the image compression. Coding is another concept wherein you may code it into some form so that it is easily understood. And as mentioned in the earlier case, we would also apply some frequency techniques to the image like wavelet analysis. Different methods, techniques could be applied to an image to convert it into a form that is necessary for the user to understand and analyze what is going to be there in that particular image. Image segmentation is one such concept. There is also the representation and description of the image, which tells us how we could represent an image, and the recognition and interpretation. As I mentioned, if a crow is sitting on a tree, we would like to recognize the crow and interpret that it is sitting at a height of, say, 6 meters from the ground. So that particular interpretation requires a lot of analysis, and this is not possible without various concepts of image processing. Next, in order to acquire images, we would see that most of us are aware of various methods of imaging. The first one is called as the reflective mode imaging. Most of us are familiar of this. This is the simple one where the sensor acquires the digital image and it converts the light energy to the electrical signals. The transmissive imaging is the second one I would like to discuss. The reason being, this is something which we are familiar, because the example of that is X-ray and ultrasound, where the radiation is absorbed to some extent by the object depending upon the nature of the material, and it is basically based on the fact that the radiation source is going to illuminate the object, and the absorption of the radiation by the objects depends on the material of the object. As mentioned, some radiation passes through the object, and that tells us some details about the object. The last one is the emissive type of imaging, which is going to be basically based on objects which are self-luminous. I was mentioning about thermal imaging, and magnetic resonance imaging are the best examples of emissive type imaging. The radiation emitted and captured by the sensor comes under the category of emissive type imaging. Next, let us go on to a few examples of different types of camera that is generally existing. Most of us are familiar with the basic camera, the video camera, the infrared camera, range camera, line scan camera, hyperspectral camera, omnidirectional camera, and much more. I am not going too deep into the different types of camera. The reason being, most of these things maybe you are aware of it, and I was mentioning about satellite imaging. For that, usually we may prefer to go for a hyperspectral camera. So this depends upon what is your application and how are you going to acquire the images. So this forms our first step, and we assume that we have done it effectively using either the simple mobile camera or any type of this more complicated or complex camera depending upon our application. Next, we will go on to what is going to be the classification of an image. When we talk about images, we would like to say that images could be represented based on attributes as raster and vector, and color images, which could be, I mentioned earlier, it could be binary, it could be grayscale, it could be true color, pseudo color. I'm not discussing here, though it exists. It is more complicated than the usual color image. And based on dimensions, usually you are aware that images is 2D. Sometimes this becomes a video, which is a 3D, which could be converted into an image by considering it frame by frame basis. And the most important of the image concept is the data type that is involved, that is a signed integer, unsigned integer, a float, a logical one, or a double, where you will see that sometimes MATLAB, especially when you're implementing, will create some errors when the data types are not matching. So we will first start with the first type of attribute, namely the raster or the vector type of images. Then we will go on to the color type of images, and dimensions and data types we were not going to discuss because data types is a problem that we will be handling through the lab implementation. So let us go on to the raster type representation. The raster type representation is the usual representation. The reason being, what is being done is the image is broken into grids, which means you could see here it is all uniform, and these grids represents x and y directions, and the number of x and number of y depends upon what type of image you require. And as was mentioned here, f represents the intensity. Here, if it is green, it may have some value. If it is white, it may have some other value. If it is blue, it may have some other value. Going to be the basic intensity concept of an image. However, an image could have x and y coordinates. I'm not going too deep into it. It could be called 0, 0, 0, 1, 0, 2, etc. We will see how the rows and columns are numbered at a later stage. At present, we will just think of the basics. That is, we have an image, and this image we would like to divide it into grids which are of uniform size, and these grids are, as has been mentioned, represent the image which is broken into the grid. As a result, they are called as pixel maps because each of these smaller grids is called as a pixel. Type of image is what is generally used in computer graphics. It is more of an object-oriented representation, and it does not show the information of an individual pixel, but shows information of an object like circle, line, square, etc. And this is more complicated. This is not going to be mostly considered in our discussion. However, since it's a basic form of an image representation, we would like to consider. For example, a circle would have coordinates 100, 20, 20, where this would represent the area and this would represent x and y. Similarly, lines would be the starting point of x and y and the ending point of x and y, etc. would represent for the various 4 lines as xb1, yb1, xb2, yb2. Similarly, xc1, yc1, xc2, yc2, so on. This tells us that we could have computer graphic representation, or what we call the object-oriented representation, in the form of, as the term says, objects as circles, line and square. Square has not been included in this particular presentation. Next, we move on to what could be an image processing application. A simple image processing application could have, you could see, the image input could also be an image, the output could also be an image. And the only implementation that we would have done would be either we would have increased the brightness, or we would have removed the contrast, we would have increased contrast, etc. You could see some of the examples which is shown. Could contrast improvement also be an application? Your problem requires. The next case that we are going to discuss is going to be an image analysis application, where we are going to say that we have taken an image and we are going to count the number of objects that is present in an image. These are just some examples to tell you what is the need of image processing. For example, you could have an image where you have a photograph which is going to consider a few seats, and you would like to count how many seats are present there. For a human being, it is very simple. You can just count the seats and tell there are 10 seats in this particular photograph. However, when it comes to the image processing problem, this problem becomes difficult because of the fact that you need to, first and foremost, if you see this image, you can see that it is quite dark. So we need to do some image enhancement problem, like increasing the brightness of an image or some such work is necessary, and only after that we could count the images. And when we are counting this, we would also see another problem, that sometimes one of the seed might be touching the other one. Then how do we count? So these are some of the basics that we would like to consider in the subject of image processing. When we talk about image processing operations, some of the operations could be either low-level operations, which are going to be pixel-based, or what we can see in our previous case, it could be grid-based. Neighborhood operation, which means between one pixel and the next pixel. Edge level, you would see these terms still coming in our future discussions. And region level, which could be based on one complete region of the image needs to be considered. For example, you may have an image which is something like a square, and half of the image might be used for one particular region, and the remaining half you would either again divide it into two more halves to consider it into a three region image. Next would be a feature level. This is one of the most important parts that I have found in any application level image processing. The reason being, many of the aspects of an image could be easily discussed with respect to features. One of the best examples of this is going to be a simple face recognition problem. For us, mostly the face recognition looks to be a simple problem, but you can think of it is very simple when you're facing the camera, but have you ever thought of what would be the difficulty if you are having your face sideways? Could I detect Jaydeep as Jaydeep if he is standing straight, or if he is standing with 90 degree to the camera, or 120 degree towards the camera? This is a real challenge, and this could be done by various features that could be considered about the image. So these are some of the ways in which we could analyze the images, and these are some of the methods which we would be using for all these operations like image enhancement. This is basically improving the contrast of the image compression, where we would reduce the size of the image and make it more smaller, image synthesis, where we would like to go in for analyzing and synthesizing what is present in the image, how we could change it, etc. Image restoration, this is especially suitable in cases where you have old images, you would like to restore it and you would like to bring back to the older conditions. Especially you could have seen nowadays that in cyber crimes, etc. In crime field, this image restoration is an important problem. Image analysis we have just now seen, it would mean counting of the objects, or it would just mean increasing the enhancement, or what you call the brightness of the image. Feature extraction could be based on the area of a particular region. Could we say that, okay, if my face is going to be say 10 by 10, could I say that this is me? If my some part is like this, could I distinguish with respect to different features what is the basic idea of feature extraction? And this is one of the major problems of image processing. And finally, image segmentation. There are much more where we segment an image, and various algorithms are available to understand how an image could be segmented and understood. And finally, we would like to go on to the last part of our discussion. What are some of the applications of image processing? Fingerprint retrieval, automatic target recognition, industrial inspection, medical imaging, attendance marking, traffic for smart city, smart agriculture, fault detection. The list is endless. Smart city. So many problems you would see. Image processing is very helpful. The question is, can we have a commercial software to do all the work? It is not possible. We need to write a software which would be specific to each application, and this is where it's going to be a major challenge to consider the basic problem of image processing, because each problem is specific and we need to cater to that problem in a specific